Hello, my name is Professor Nicola Pohl. I'm a professor of chemistry at Indiana University in Bloomington, Indiana. And today I'd like to tell you about some easier automated methods to make glycans that my group has been developing. Most traditional synthesis still takes place the same way that chemists have been doing things for many, many decades, for hundreds of years, using lots of cool glassware, Bunsen burners, and all the things you might see in a fun science show. But in reality, we need to start automating this chemistry to make it usable to a much broader community than just synthetic organic chemists. And so that's what I'd like to tell you about today, is some of the work we're using to be able to automate sugar synthesis so we can string individual sugar building blocks together to make larger sugar glycans and glycolipids and glycopeptides. So we've developed a quite complex automation platform that's shown here, where we have an expensive machine that allows us to deliver the reagents, the computer programs times everything so we know exactly when things are delivered, and the entire process can be automated from the beginning to the end. This has worked quite well for over a decade, but it's quite challenging if you don't have the money and the expertise to actually build and maintain this kind of machine. So what I'd like to tell you about now is essentially version 2.0, the more user-friendly, the easier way to do this so that either you or one of your friends or a contract synthesis company can more readily make glycans or sugars. So the idea is to have a synthesizer that is easy enough to build, mix and mash, just like Lego. And if you actually were standing in front of a synthesizer and took the plastic covering off, what you'd see is a bunch of ways of delivering reagents, delivering liquids, as well as being able to switch between one liquid reagent and another liquid reagent. So essentially, if we had control of both the liquid handling pumps and the switching valves, we should be able to make any kind of synthesizer, one that can make sugars, one that can make peptides, or one that can make the building blocks that need to feed these sugar synthesizers. So how do we go about doing that? So my group has developed, in collaboration with Brad Penelude's lab and researchers at Radcliffe Institute, a method to program individual pieces. So here is a pump. You will see this in many different labs, not just chemistry labs, but a lot of biology labs, engineering labs. It basically is just a way of controlling the way that liquid flows. So if we could control this, we would be able to get one sugar building block to flow against another sugar building block and bring the two together and couple them into a larger structure. Not only that, but ideally, I would have everything in a program that I could share with you online through GitHub, GitLab, and you'd be able to build not only the apparatus, but also control it so you can make the sugar yourself. And so the way we've gone about doing that is using a simple Python code that controls both the liquid handling pumps as well as switching valves, and then we can bring all of this together to be able to make glycans in a simple, easy way. So this is part of a larger process whereby we can put sensors and basically get the entire community to help bring all these different parts together. As one lab creates something, another lab can use it, and we bring all these different parts together to be able to create any synthesizer. So at this point, if you want to bring two sugar building blocks together, we can easily set you up to be able to take these very inexpensive pumps and switching valves and set that synthesizer up in your very own lab. If you're feeling handy, you can also just get the code and then be able to build that sugar. And the nice thing is, as you might make an innovation and find some little tweak, perhaps with your own special sugar building block, that code can be modified and shared with anyone around the world. And so that's how we see the progress, not only for making glycans themselves, but also being able to develop the automated synthesis of the building blocks that need to go into the glycan synthesizers, how we can go forward as a community. I'd love to tell you more about this. Feel free to contact me at npohl@indiana.edu, and I'd love to help you be able to implement this kind of synthesizer in your own lab. Thank you.